3.1, day 1. So we're going to spend 2 days in section 3.1. Start you off with some basic foundational terminology. Because if you don't understand the terminology, then you have a really hard time understanding what it is the author of your math book and tests are even asking. So let's go over some of this terminology. So first of all, they're going to say, find the degree of the following polynomial. So what the heck is a polynomial? Well, a monomial means one term, like 3x. Bi means 2. You've heard of binomials. You factor a trinomial into 2 binomials, so you're kind of used to that. That can be x, plus 2, something like that. Or even x squared plus 2. It just has 2 terms. That's it, okay? Trinomial, you guys are used to these. X squared minus 3x plus 4. That's your typical trinomial, okay? Now, you could have 4 terms, 5 terms, 6 terms, and I'm not even sure what the names of those are. I could look it up, but it's not that significant. So, here's one that I'm not even sure what the name of it is, but it's got 1, 2, 3, 4, 5 different terms. So there are questions that simple, like how many terms does this polynomial have? And you say 5. So now, when they say put it in standard form, what they're saying is, look at the highest power of all 5 of your terms, or 6 of your terms, or 8 of your terms, and just put it the highest power first. You're used to doing this with trinomials before you factor them. Now they're just going to get a little bit more complex because the numbers are bigger. So what's the next highest power? That'd be a 5. So I'm going to put my x to the 5th next, then my x to the 4th. And notice, I don't care about these coefficients. They have nothing to do with putting things in decreasing order, okay? So minus 3x to the 4th. Next one, there are no cubes. So I'm going to go with 4x squared and then minus 8x. So there, you put it in standard form. Another way of thinking that is just putting it in decreasing degree of the powers. Now, the powers we're going to talk about. Now, what's the leading coefficient? The leading coefficient is not necessarily the 1 from the original problem. It's going to be the coefficient of the leading term after you put it in decreasing order. So the leading coefficient in this case is a 2. Now you could have just looked at this and went, oh, there's my highest power. My leading coefficient is going to be a 2. You don't really need to put it in descending order like this to get your answer. But get in the habit of doing this. There's going to be a reason why. But now what's the degree of the polynomial? It's the power. It's the highest power of any one term. And the reason we put this term first was because this was the highest power. So the degree is the power of the leading term after you put it in standard form. I know that's a mouthful. So that would be 6. Now, let's take these ideas and apply them to these. A monomial, well, what's the standard form? Well, you can't rearrange that. It's already in standard form. What's the leading coefficient? 3. What's the degree? Well, there's an invisible 1 there, so my degree would be 1. How about this one? Well, standard form, it's already in decreasing degree. So leading coefficient would be this little invisible 1. And let's look at this one, the trinomial. What's standard form? Well, we put it in decreasing. There's a 2, there's a 1, and there's nothing, so that's now in standard form. What's the leading coefficient? Once again, it's a 1. What's the degree? Well, it's the highest power in the polynomial. So my degree of this one would be 2. There's a good warm-up. Okay, now we're going to progress into a new term to you guys. And this is something that's big in calculus. So again, this is Algebra 2. It's a foundation. It's getting you used to the language you're going to need down the road. You're going to need it in this class. But it's really setting the stage for, you sign up for a calculus class and your calc professor or teacher is going to talk about end behavior like it's 2 plus 2. So now you just have to get used to it. You have to be introduced to it. but it gets a little tricky with the words and how to think. So first of all, I want you to think why. You don't know what that means yet, but I'm going to explain. So they're going to ask you things like this. Now this is an easier example compared to stuff that's going to be on your homework. But let's just start here with something you're very familiar with, and that's a line. So if I was to graph this, my y-intercept would be 3, up to right 1, and I'd draw it. Now here it comes. They're just going to ask you, hey guys, what's the end behavior of this? Now sometimes they'll just give you the graph and you have to determine what the end behavior is. Other times they won't give you the graph and they'll just expect you to know some rules. That's where I'm headed. I want you to just know some rules, but here we go. The end behavior, let's see if I can put this in the right words. Think of it this way. There's always two answers to this. One of them is, if you were to travel along this, and I'm going to go back to the roller coaster thing, so there's your little cart, and your roller coaster cart is heading left towards negative infinity forever. Now, the question is, hey, how do I think why? Well, it's really simple. This is very similar to, is it going to be increasing or decreasing? Very similar. Well, this would be decreasing if I'm moving left. If I'm moving that way, this cart would be going down. How long would it go down? Forever, because of that arrow. So the y value right here is, how far down will it go? Well, it's going to go to negative infinity. So one of them, as x moves to negative infinity, my end behavior, and I'm not going to write this down every time, is also negative infinity. Now this is my y value, that's my answer, but this is the direction I need to go in order to get my answer in terms of y. Now let's change it. What about as x moves to positive infinity? Well, we're going to erase this, and we're going to change the direction. As x moves to positive infinity, it means, all right, now this cart is trying to move this way on that roller coaster ride. It has to go up as it moves to the right. To the right means towards infinity. But where does the y go as the roller coaster is going this way? It's going up. So now this answer would be positive infinity. Now some of you guys looking for patterns, it's like, are these always going to match? No. So be careful with that rule. Now listen, there's a review. This is the same graph as this, but notice I got a negative. What have we learned about that? If a is negative, it reflects over the x-axis. So that just means this whole thing is going to flip. So we got, my y-intercept is still the same, 3, but this, instead of going up to the right, is going to go down to the right. This, instead of going down, is going to go up. So it just took the whole thing and flipped it. And so now we're going to ask the question, what is the end behavior? Whoops, behavior. Well, so here we go. You always go this way. Here's your roller coaster ride. As your little cart is trying to move left, it can only go one way, up. So my end behavior, as x goes towards negative infinity, my end behavior would be infinity. That's my answer, because it's my y that's always my end behavior. Now what if I switch that? What if x is now heading towards infinity, which means now we're going to reverse the direction. This thing is trying to move to the right, but it has to stay on the tracks. This roller coaster is going down, 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 down forever. And there's my answer. As x approaches positive infinity, moving to the right, it's going down. Let's apply it to something else. This is a quadratic, something you're used to. If I was to graph this, I'd say, hey, This is parabola, 2 to the right, and then it goes up 1. So there it is right there, and because that's a 1, it's normal, and there it is. Now, I drew that too small to put a little roller coaster guy on there, but maybe I'll just draw a little, there we go, a little one. All right, there it is. So, what's the end behavior? Remember, there's two answers. There's x approaching negative infinity, and then there's x approaching positive infinity. So I'm going to put a little colon right there. This is just telling you the directions you need to go. So start with thinking, okay, my roller coaster ride is moving left, but it has to stay attached to the roller coaster. So it's moving left, has to go up. Those arrows mean up and up and up forever. So my end behavior would be positive infinity. Now what about if I change directions? What if I took my roller coaster ride and I went to the right? Well, it has to go up. So both of my answers are the same. Now let's do something here, and let's take this and actually apply it. Give me a second here. Okay, so that negative, what's that going to do? Well, our terminology is it flips it over the x-axis. But don't be fooled, this doesn't move. Okay, that point, x is 2, 1. If I was to put in a 2 for x, and I plug it in there, 2 minus 2 is 0, 0 squared 0, negative 0, 0, I still get 2, 1. So how do I flip this over the x-axis? It just flips. That's all this does to that graph. So that would look more like this. Now, is that perfect? No. But let's talk end behavior. As x approaches negative infinity, that's a bad one, but I'm keeping it. So here's my roller coaster ride. This is going to be a fun one. As I move left, I have to go screaming down, which means my end behavior is going to be negative infinity as x approaches going the left direction. What if I go the other direction? Well, that's also, whoa, negative infinity. So as x approaches positive infinity, which means as your roller coaster tries to go to the right, but it's attached to this roller coaster ride, it's going to go down. So that would be my answer, negative infinity for both of these. Now we're going to summarize some things, and this is going to require 2 parts. So I'm sorry for the length of this pre-lesson, but it's really going to make sense in the second video. I've only got about 2 more minutes on this, so hang tough. I want you guys to notice something. This is an even power, and generally speaking, it goes up and it goes up. When I switch that, generally speaking, the outside of it goes down and down. And we're going to build on that, so keep that in mind as we continue. Okay, more on the end behavior. I'm going to try to pull it together a little bit now. Notice I got a purple, y equals x cubed, and I've got the graph right here. Now, are you supposed to have memorized what y equals x cubed looks like? Not yet, but you'll get familiar with it. But the point I'm trying to make is, notice this is an odd power, and this is an odd power. Now, this is just y equals x, the red line, and I want you to notice on both of them, as x approaches negative infinity, so I've got my roller coaster guy here, and I got my roller coaster guy attached there. That's a scary ride. But as x, my roller coaster little buggy, moves left, both of these different paths, but they're going down. So both of these are going to be negative infinity. What about if I change directions and my roller coaster here goes up to the right, as I try to go to the right, and as this guy goes to the right, they both are going to go up and up and up. So what about y equals x to the 5th? What does that look like? Well, we don't really know, but what I'm trying to hone in on is you don't have to know. If that's odd, your answers are going to be the same. Now, let me pause that a second. Yeah, I only got 30 seconds. So last 30 seconds, what if I put a negative on this one? Well, it would flip everything. And if I flip everything, that would, and the same thing if I put a negative in front of that, it's going to flip the line over the x-axis. Same thing with the purple one and the red one. So my end behaviors would be opposite. So that one would be positive infinity as x approaches negative infinity, and this one would be negative infinity, because it would just flip.